Today we are going to discuss about the metallic bonding. What is metallic bonding? Before start this topic, recall your ionic bonding and covalent bonding. If you recall your ionic bonding, then you know this metals and non-metals react together by the complete transfer of electrons. They form ionic bonding because ions, positive and negative ions, are formed. Due to the ion formation, ionic bonding is formed. Due to these ions, atoms feel electrostatic forces of attraction between them and they combine together. If you recall your covalent bonding, you know that in a covalent bonding, non-metals and non-metals react together. How they react? By sharing their electrons, by sharing their valence electrons with each other, they combine together and make a covalent bonding. Covalent bonding take place in non-metals and ionic bonding take place in metals and non-metals. But what is metallic bonding? Metallic bonding happens in metals. Both the atoms will be metals. Both the atoms will be metals. When metallic atoms combine together, attracts towards each other, they will make metallic bonding. They will make metallic bonding. Here is the common example. Calcium is a metal, as we know this. Calcium belongs to the second group. First and the second group all are metals. First group elements are alkali metals and the second group elements are alkaline earth matter. So calcium is alkaline earth matter. When all the atoms of the metals combine together make metallic bonding, becomes a metal, strong metal. This is the basic characteristics of the metals, that they having a metallic bonding. For example, all the atoms of the potassium are combining together due to the metallic bonding. All the metals, no any other thing, all should be metals. In ionic, metals plus non-metals. In covalent bonding, non-metals and non-metals bind. But in metallic bonding, only metals bind together. So due to that, they form metallic bonding. What is basically happening in a metallic bonding? How metals combine together or come closer to each other? As we know, electrons are revolving around the nucleus. Electrons are revolving around the nucleus in a shells, in a specific energy levels. For example, this is a sodium metal. All are the atoms of sodium. Sodium having one electron in its outermost shell. So all the sodium atoms having one electron in its outermost shell. Here you can see all the sodium metals having one electron in their outermost shell. When all these metals are come closer to each other, they having an attraction for all the electrons. This sodium metal, this sodium atom having attraction for this electron, for this electron, for this electron, for this one electron. So the nucleus of the each metal, the nucleus of the each metallic atom having an attraction towards the electrons of the neighboring atoms. When this sodium atom, when the nucleus of this sodium atom feels attraction for this electron, this sodium atom lose this electron. Due to that, these electrons becomes delocalized, leave their shells, delocalized, leave their location. If they leave their location, See here, you can see here delocalization happen. All the positive centers of the atoms attract the electrons of the neighboring atoms and make them delocalize. As we know, in a metal there is a specific regular arrangement, there is a giant structure of the metal, any of the metal, but due to that delocalization of the electron, atoms feel more attraction towards each other, they come closer to each other because of the free moving electrons, because of the attraction for the electrons of the other atom, because of the attraction of the electrons of the neighboring atom. Each atom is come closer to each other and make a strong bonding. Between these bonding, there are some free electrons. There are some free electrons. This is an electron of any of the atom of the metallic bonding. This atom is also attracting this electron. Another atom also attracting this electron. Due to that electrostatic force, due to that electrostatic attraction towards the electron by each of the nucleus of the metallic atom, hold each other tightly in a regular structure. In this way, due to this, metals having a high melting and a boiling point, because all the nucleus is attracting all the electrons, that's why they are very strong. Due to that strong nature of the metals, you need high temperature to boil the metals, you need high temperature to melt the metal, and due to these free electrons between the metals, between the nucleuses of the metals, because of these free electrons, metals conduct electricity, metals conduct heat because of these electrons, because of these electrons. As we know, electricity is conducted when there are ions, when there are free electrons. If there is no free electron, if there is no ions, then no conduction of electricity or heat takes place, as we see in covalent bonding. In a covalent bonding, no charges are formed, no ions are formed, and no free electrons are present. Due to that, there is no heat and electricity conduction in covalent compounds. But in ionic compound, electricity is conduct, heat is conduct if they are in the solution form due to the ions. And in metallic bonding, metals also conduct electricity and a heat because of the free moving electron. How these electrons move freely? Because each electron is attracted towards the nucleus of the all the atoms of the metal. Due to the electrostatic force towards the electron by all the neighboring atoms, these electrons move out from their valence shells and becomes delocalized. Due to this delocalization of the electrons, metals conduct electricity. Metals allow electricity and heat to pass. As we know, metals are very rigid, not that much, but they are very strong. Metals having atoms, and between these atoms there are free electrons. There are free electrons. If you are providing heat to the metal, providing heat, these atoms start vibrating. Due to that vibration, the heat from the electrons to other electrons pass out. Due to that vibrations, heat from the electrons move towards the other electrons. In this way, whole piece of the metal becomes heat up. Due to that electrons movement, due to that free or delocalized electrons in a metals. And metallic bonding only takes place in metals. Ionic bonding between metals and non-metals, don't forget. Covalent bonding between non-metals, and metallic bonding between metals only. What is sea of electrons? As I am saying again and again, there are free electrons, delocalized electrons, because each atom attracts the electrons of the neighboring atoms. Due to that attraction towards the other electrons, all the electrons start moving freely. between these atoms. So due to that free movement of the electrons between the atoms, that's why we say it sea of electrons. If an exam question is related about what is sea of electrons, then you have to explain the metallic bonding, that atoms having attraction for the electrons of the neighboring atom. Due to that electrostatic forces of attraction for the electrons of the other atom, electrons move out or release out from their valence shell, delocalize, start moving freely between all the atoms. So when electrons are moving freely between the positive centers, these are positive. Because of the release of the electrons, atoms becomes positive ions. As we know, if the atom releases its electron, it becomes positive. By the release of the electron, atoms become positive. So the metals, due to the electropositive nature, they easily release their electrons, becomes positive ion, become positive ion. So now in this medium, there are free electrons and there are positive ions. There are free electrons and there are positive ions. So these free electrons are saying as the metals having sea of electrons, because electrons are freely moving. There is a sea of electrons. So if the question is about sea of electrons, then remember, you have to explain the metallic bonding. Electrons are freely moving in a metals. Metals release their outermost shell because all the metals nucleus attracting the electrons of the neighboring atoms. Due to that, electrons are removed from the valence shell. Electrons are delocalized, freely moving between all the positive centers. That's why it is called as sea of electrons. Here you can see the sea of electron. See, electrons are not properly arranged. Electrons are freely moving. These negative charges are basically electrons. And due to the release of these electrons, metals carry positive charges. So, in a metallic bonding, positive and negative charges are basically observed. Due to that attraction between positive and the negative electrons, between the positive nucleus and the freely moving electron, you need a very high energy to break these bondings. That's why metals having a very high melting and a boiling point, because attractions are very strong. If you want to break these attractions, you need a very high amount of energy. Next, here you can see some properties of the metals. Metals are malleable. What does it mean metals are malleable? Malleables mean you can bend or hammer them. You can easily bend the metal or hammer them to change into other shapes. You know that metals exist in a many forms, in a thin sheets, in the form of wires, in the form of different equipments, because metals having a malleable. This is a very important property of metals. Metals are strong, but they are not as much rigid that you cannot break it. You can change it into another form because of their sliding nature. Why the atoms of the metal slide over each other? Here you can see the pure metal. Only pure matter having a property of malleable. Only pure metals are malleable. And ductile. Ductile means, this is also a property of a metal. Ductiles mean you can change the metal in the form of wires. You have seen the copper wires, they are very thin. So metals having a property that you can change their shape, because in a pure metals, atoms slide over each other. Why they slide over each other? Because they having a freely moving electrons. Due to that freely moving electron between the atoms of the metal, they slide over each other. Due to that sliding nature, you can easily change them into any shape. You can change them into thin sheets. You can change them into wires. You can make many materials from the metals by changing their shape. As I told you before, they having a very high melting and boiling point because they having a very strong attraction. Positive nucleus and the freely moving electrons having a very high attraction towards each other. That's why they're having a very high melting and a boiling point. They conduct electricity because they're having a free electrons. Electricity only conduct when they're having a free electrons and when they're having a ions. So in a metallic bonding, they having a freely moving electrons. So that's why metals are best conductor of electricity. We study this from our junior classes that metals are a good conductor of electricity. Metals are a good conductor of why? Because they having a freely moving electron. That's why they conduct electricity. What about alloy? What is alloy? Alloy, as we know, the mixture of more than two metals or any other element mixed in a pure metal, then that material is alloy. Alloy is very hard and rigid. If you want to make a metal hard, so you have to make it alloy. Gold in a pure form is very soft. Gold is easily break. You can break the pure gold metal by your hands because that is very soft. How the jewelry we wear of made up of gold is very hard because that gold having some impurities. Any other metal is added into it. We have made that gold alloy because of the addition of the impurities to make it hard. Otherwise, we cannot wear the gold because gold naturally is very soft. So, by adding another material, another metal into the pure metal, we are making it hard. For example, iron is a metal, and iron in a pure form is very, not very much, but it's strong, but not that much hard. So how we can make it hard? By adding another. For example, we are adding it carbon, another metal, and we are adding another material. Carbon is not a metal, it's a non-metal, but we are adding another material to make it stronger, due to the addition of the any other metal. The arrangement of the metal changes because one atom is smaller in size, other metal is larger inside. One element is smaller, other element is larger. Due to that irregular shapes of the different elements, atoms do not slide over each other. When they do not slide over each other, then they are very hard. Metals are only have a soft nature because of their sliding nature. If the atoms in a metals do not slide over each other because of the impurity, this is considered as an impurity. You have added something out of the pure metal. Now this is not a pure metal, you have added something in it. That's why they do not slide over each other and they are impure. Iron is a pure metal. This is iron. How steel forms? If you add 1 to 2% of carbon or chromium, magnesium or vanadium, these are the different metals. When you add different proportions of different metals in an iron, then it will become steel. According to our choice, in cars, in aeroplanes, steel is used. Steel of different nature. Maybe that steel having more amount of chromium, more amount of magnesium, more amount of vanadium. It's up to us that what we want, what type of property we need. Because of the change of the amount of these different materials in an iron, their nature changes. According to our choice, what we want, we change the nature of the steel.